Hello and welcome everybody. This is Noah, and in this video we're going to do an introductory application of a rational equation. All right. Used to introduce these rational equations, we're going to look at you going on a boat trip 12 miles down river and then back. So we're going to have a starting location. We're going to go 12 miles down river. This is downriver, so the river is flowing this way. It says the river flows at a speed of 2 miles per hour, so it's 2 miles per hour. Make note of that. And then we're going to turn around and go back to where we started, and that's another 12 miles. If we row the boat at a constant rate of v miles per hour for the entire trip, you can model the total time it takes for the trip with the function t of v equals 12 over v plus 2 plus 12 over v minus 2, where t is the time in hours. So let's make note that the output, actually I'm going to put this above here, the output of this function is time in hours, and the input is speed in miles per hour. What we want to do is we're going to graph this function and use it to determine the rate we should row if we want to complete the trip in 8 hours. And we're going to do the same thing symbolically. So let's go ahead and kind of break down this equation a little bit, see where it comes from, so we can, not feel like this is some sort of magic formula. We're going to start with the idea that distance equals speed times time. And even if you haven't memorized this formula, even if you're not familiar with it formally, it is something that we are familiar with generally in our lives as we travel from one place to another. For example, if we are going 60 miles per hour and we drive for 2 hours, then we know that we have driven 120 miles in total because we went 20 miles or 60 miles in the first hour and another 60 miles in the second hour. So in total, we've gone 120 miles. So if we accept that this always works, and it very much does, then we can rearrange it for time. We can note that time equals distance divided by speed. Okay? So if we take that original equation, the distance equals speed times time, and we divide the speed over to the other side, we can see that the total time is going to be the distance traveled divided by the speed that we are going. Now, in this particular problem, we look at the speed that we're rowing as a constant speed. So we're just going to keep rowing at the exact same speed, no matter we're going downriver or upriver. But if we're going downriver, the speed of the river, which is going 2 miles an hour, is going to push us forward faster. So we have the speed that we're rowing, and then we add the 2 miles an hour of the river, and that's the speed that we traveled downstream. And so the trip downstream was 12 miles. So if we go 12 miles, the distance divided by the speed that we're going downriver, then this first fraction here, the 12 over v plus 2, that is the time that it takes us to get down the river. And then on the way back, we're again going 12 miles, but the speed is going to be how fast we're rowing, which is the same as it was before, but now the river's pushing against us, so we're going to be going 2 miles per hour slower than how fast we're rowing due to that current. So this second fraction, 12 over v minus 2, is the time it takes for us to get back. We add these two times together, and that will give us the total time of the trip. So that's where this comes from. And make some good notes of how this is being put together. Definitely make note of these two equations on the right, especially if you're not familiar with them, as they are going to reappear in later parts of solving rational equations. So now that we've got the basics out of the way, now that we see kind of where this function is coming from, let's go ahead and graph it and then use that graph to be able to find out how fast we should row in order to complete the trip in 8 hours. So I've got GeoGebra pulled up here, and let me just restart all of this. I'm going to start by putting in the function t of v equals 12 over v plus 2 plus 12 over v minus 2. And so we want to just interpret this as I'm moving on this line. I only want to consider positive velocity. So the horizontal axis is our speed, our velocity, and the vertical axis is the total time that it takes for the trip. We only want to consider the first quadrant over here where our speed is positive, right? We only want to consider like any speed. We need to be rowing at least, we need to be rowing more than 2 miles an hour if we're going to finish this trip at all. Otherwise, we wouldn't be able to fight against the current on the way back. So we really want to be focusing on velocities that are over here, that are greater than 2. And then we can see that if I look at any point on this line, and I say, okay, if this is like 2.2 or 2.3, and the output is 30, that means if I'm going 2.2 miles per hour, it's going to take me 30 hours to finish the trip. And we definitely don't want that. You can see as we come down, a vertical value of 8 is right in here. And it looks like the speed that we're going, the horizontal value here, is probably 4, but we want to confirm that. So what we can do is we can type in y equals 8, and I need to use y equals, otherwise the computer will get confused here, and it won't allow me to type t equals 8 without like ruining this whole thing. I tried, it failed. The computer normally thinks of the vertical axis as y, so we say y equals 8, and it will give us this horizontal line. And now I want to find this intersection. And it's not doing it automatically, which is a little frustrating, but that's because these are two different kinds of objects here. This is a function, and then this is an equation y equals 8 that it's graphing. So GeoGebra is not exactly sure how to automatically find that intersection, but we can force it by typing intersect. And then I'll tell it the two objects I want to intersect, t and f. And we'll notice that it does give us an intersection over here. And there is an intersection there, but that one doesn't actually make sense in context. That would be saying that we're rowing backwards somehow. So in context, we want to find this intersection. So I can tell it that by putting some more information here. I'm going to tell it to look between 0 and 5, right? Oops, comma 5. So I tell it the two numbers to look between, and then it goes ahead and pops that up. You can see it's the 0.48. I can also switch this so that I can see it right there. And there we go. That's all of the information we need on this. Zoom in, take a screenshot so we can draw all over it if we want to. Back over here. Oops. And put this in so we can look at it. Okay, so we can just remember that the x value is actually a v value. That's our speed. And this is the time. And this is a point on our function. And so we now know the answer, that if we row 4 miles an hour, then it will take us a total time of 8 hours to finish the trip. So let's go ahead and conclude that. If we row a constant 4 miles per hour both ways, the total trip will take 8 hours. Cool. All right, so we know the answer. And now we want to do the same thing, find the same answer symbolically. And this is what we're going to be focusing on a good amount in these lessons here. We've solved equations graphically in the past, and so we are going to do some more of that here, but we also have never seen solving a rational equation symbolically, so that's another thing that we really want to spend some time on. So the total trip, we want to take 8 hours. Now, that's the output for this function, so we can plug in 8 for the output for the time of the trip, and then we're looking for the speed, so we're going to be trying to solve for v here. And we'll be going over a lot of these techniques and moves that I use in following videos, but I'm going to go through it and try and at least give some general ideas of how to do this right now. So I'm going to look at the denominators, and I'm going to say the common denominator here is v plus 2, common denominator, is v plus 2 times v minus 2. And if I take and multiply the entire right side by v plus 2, v minus 2, well, I would be changing the equation if I just did it to one side, so I have to do it to the other side as well. But if we do this, then these are going to distribute to both of the fractions here on the right side, both of those rational expressions. So let's see how this plays out. On the left side, I'm going to go ahead and FOIL these. I'll get v squared minus 4. The middle terms will cancel with a minus 2v and a plus 2v, and I have that 8 in front of there. Over here, I'm going to do this in a couple of steps. I'm going to keep the 12 over v plus 2, and then we're multiplying this by v plus 2, v minus 2, and then this plus is going to go right there. And then I have the second fraction, 12 over v minus 2, and this is going to get multiplied by v plus 2 times v minus 2. Nice. So what we can do right away here is we can cancel the v plus 2's, and then in the second fraction we can cancel the v minus 2's. And if you're really astute, you might notice that the domain just changed, and I don't know that we're going to worry about that for this problem, but that can come into play in these. So the reason that we multiplied by the common denominator was specifically to clear the denominators of those fractions right there so that we no longer have fractions involved in the equation. We turn this from a rational equation into something that doesn't have a denominator, so it's no longer rational. On the left side, we'll now have 8v squared minus 4 times 8 is 32. On the right side, we'll have 12 times v minus 2 plus 12 times v plus 2 after canceling the v plus 2 on the first fraction and the v minus 2 on the second fraction. All right. I think I'm going to need a little more space here. Let's go ahead and do that real quick. And let's distribute the 12s and combine like terms on the right side there. We'll have 12v minus 24 plus 12v plus 24. We can cancel the 24s, minus 24 and plus 24. And so we'll have 8v squared minus 32 equals 24v. And then we need some bells to go off. And specifically, we want to be recognizing that's a square right there, and that's a first degree. So we want to say, oh, we need to set this to 0. We need to subtract everything to one side. And solve a quadratic equation. Which we have definitely spent some good time in this class doing. So more of that now. So we turn this rational equation into a quadratic equation, and then we can solve that. So I subtracted the 24 over to the other side, and now we can go ahead and look at solving this quadratic. Now the first thing we can do here is we could factor out an 8, because 8 goes into 24 3 times, 8 goes into 32 4 times. So if I factor that out, I'm left with v squared minus 3v minus 4 equals 0. And then we can factor the v squared minus 3v minus 4, right? Or hopefully, let's just take a look. And we need a v in the first position. We want a 4 and a 1 in the second with a minus 4 and a plus 1 so that these add up to negative 4v, and a plus 1v adds to minus 3v here in the middle. And so we now have 3 things being multiplied equal to 0, so one of them has to be 0. That means v plus 1 has to be 0, or v minus 4 equals 0. The 8 is definitely not the thing that is equal to 0. That is just the number 8. So we don't have to worry about that one. We'll solve these. We'll get v equals negative 1 or v equals positive 4. The negative 1 we can disregard for this problem because that's outside of, that would be us saying that we're rowing backwards. We're clearly not going to get there. If we're rowing backwards, we only want to consider positive speeds that we're rowing. So this right here is our answer. If we row 4 miles per hour, the total trip will take 8 hours. All right, so a lot happened here, and I'm not saying that you're going to go and try this very next problem and get it you can't come up with. In the next video, we'll go ahead and walk through the solution to the now you try problem. All right, thanks so much for watching, everyone. We will see you shortly.